Pictured here is my brother's MRI results. Last year around this time, we received the terrible news of him suffering from stage 4 brain cancer. And unfortunately, my dear brother passed away due to metastasis without doctors noticing. Cancer, ladies and gentlemen, annually around 10 million innocent people are dying due to this deadly disease. It's the death cause of 1 in 4 Canadians. Just like me, some of you have also probably lost loved ones due to cancer. My name is Mansoureh, PhD student in biomedical engineering, and I believe that my thesis will have an effect in cancer studies, support oncologists and pharmacists to deal with their challenges. Do you know what are the challenges they've been faced with? I will tell you. One of the most important ones is the lack of having an artificial tissue model to portray the complexity of tumor microenvironment and mimic intercellular interaction exactly like our natural tissues. Well, what is my thesis proposing for this challenge? I designed an innovative 3D co-culture to reproduce a cancer tissue. It's able to monitor tumor cells to see if they are aggressive, showing metastasis or not, and then apply it for customized cancer chemotherapy drug screening. I'm sure you are curious how I developed the model. As you see in the center image, I made a polymeric nanofibrous scaffold, activate the surface by plasma to promote cell adhesion, and then seed it with a variety of healthy cells. And finally, a layer of hydrogel-containing tumor cell is loaded on top of the scaffold as a representative of cancer tissues. It sounds simple and easy, but believe me, the hydrogel placement on the scaffold really killed me until it reached the optimized format. Actually, I'm working in a multidisciplinary area dealing with biomaterials, physics and plasma, cells and biological tests, which is very time-consuming process. You know, it's really hard sitting under the hood for hours, repeatedly pipetting up and down liquids in transparent place while getting contraction in muscles, but it's worth it when you get the result. Anyway, I successfully applied a model of breast cancer metastasized to bone and screened it with doxorubicin as a famous drug for breast cancer. The data of the graph on the top right validate that my 3D model is working brilliantly in terms of blocking and killing breast cancer cells. My user-friendly 3D model is very competitive and comparable with the commercial expensive product named Matrigel. Another thing, it's potentially compatible with a broad range of patient-derived cells, so it can be applied to personalized medicine for patients' biopsy samples. You know, despite all my ups and downs, a dream of having a positive impact on people's life and one day being able to decrease the losses like my brother inspires me to continue and keeps pushing me forward. I believe that these kinds of approaches could bring a day in which I can proudly say cancer exists but has no victims.